Hello everyone, my name is Mpiana Mamba Malek. I'm a PhD candidate in Computer Science and Engineering Department from Korea University. In this presentation, I will be introducing SmartBuilder, which is a block-based visual programming framework for smart contract development. This is the outline of my presentation. By definition, smart contracts are typically computer programs stored on a blockchain. They run when some predefined conditions are met. They can be seen as a self-executing contract used to automate the execution of the term of agreement between participants who can be immediately certain of the outcome of the execution. Smart contract can find the application in many application industries and can be used for several use cases ranging from simple to complex. There are many challenges with smart contract development. As you know, building syntactically correct smart contract is very complex and challenging for non-expert or beginners. As smart contracts are still in the early phase, there are many issues related to that, such as there is a shortage of expertise and tool for supporting the smart contract development learning or teaching process. Most of previous studies on assisted smart contract development frameworks has been focusing on Solidity smart contracts. The need for graphical and user-friendly development framework for teaching and learning how to develop smart contract for permission blockchains such as Hyperledger Fabric. So to address this issue, we propose SmartBuilder Framework, which is a block-based visual programming framework developed for building smart contract using Blockly libraries. We target Hyperledger Fabric smart contract development in Go language. Customized and extended Blockly provided library to enable the design of smart contract using Visual Block and automatically generate related codes in Go language for smart contract. The purpose is to make it easy for non-expert programmer or smart contract development beginners to build Hyperledger Fabric smart contract implemented in Go language using visual blocks without writing any single line of code. Blockly, which is a development library, is an open source solution featuring block-based visual programming languages and editors. It is a client-side framework which doesn't require server supports. The whole library is built in JavaScript. It is designed to be highly customizable and flexible. Moreover, it is compatible with major browsers in the market. From user perspective, Blockly provide an intuitive way of building a computer program by applying programming principle without worrying about any complexity, because it's generate automatically syntactically correct code.
For the user convenience. From the developers
Perspective, Blockly is a framework which provides support for creating visual programming languages that can be used to create visual blocks that will enable a user to build a model and generate syntactically correct source code. So it can provide support for many programming languages such as JavaScript, Python, PHP, and so forth. Now, let me elaborate on Hyperledger Fabric smart contract, also known as a Chaincode. In Hyperledger Fabric blockchain community, smart contract and Chaincode terms are often used interchangeably, but there is a slight difference between those two concepts that I will explain now. A smart contract is used by decentralized application developers to define the business logic of the transaction that will be used to interact with the blockchain ledger. They are often packaged in Chaincode, which deploy to the Hyperledger blockchain network on the peer nodes. While A chaincode is typically used by administrators to package related smart contracts for deployments. They are also used for low-level system programming for Hyperledger Fabric system. So now let's have a look on the structure of a Go coded Hyperledger Fabric chaincode or smart contract. It can be divided in 5 sections. The the module and library importation part. We have the smart contract definition parts, and we have the function, the initialization function definition. You have the invoke function and the main function. In the import section, we import all the required library and modules. For example, here the shim. The shim library provide the implementation of several APIs for smart contract or chaincode to access its state variables, transaction context, and call other chaincodes. This shim library provide two interfaces for the main function to interact with the smart contract implemented function. We have the chaincode interface and the chaincode sub interfaces that are used to call the smart contract implemented function. You have the smart contracts, which is defined using the struct, and here you have the initialization function, which is defined using the init keyword. Init function is called during the installation or upgrade of the chaincode, while the invoke function is used to interact or calling any function implemented in a smart contract. And the main function uses the API provided by the shim library to call and run the smart contract. SmartBuilder Framework enable the user to model the smart contract model based on the contract requirements, and then this model made based on the visual blocks which are connected in a rational manner, and then the block-based model is passed to the code generator, which generates the source code and can export in several formats, such as blockly project formats, which can be saved and load for further modification. You have the XML script file, which contain the smart contract definition in terms of data structure and business logic implemented by the smart contract. This file can be reused by the decentralized application. And you have the smart contract source, which can be deployed in the Hyperledger blockchain network to run by the peer. You have the smart contract summary description, which is provided in the text file. Framework provide user-friendly user interface and excellent user experience. About the UI UX, you can see on the top we have the title and the menu toolbar that has several menu buttons implementing several functions. On the left, we have the Blockly toolbox list that contains several blocks, workspace provided to the user where they can connect several visual blocks to build the smart contract model, which is used by the code generator to generate automatically the smart contract source. As you can see here on the top, you have the smart contract summary, which is provided in a natural language just to make it easy for beginners to build a smart contract without worrying about the complexity of the source code. In its toolbox, you can find the blocks required to implement the initialization section of the smart contract. In the body, you will find the core block used to build the body of the smart contracts function that implement the requirements of the smart contract and the business logic. In the you will find the blocks that embed the specific functionality to implement the smart contract transaction function corresponding to create, reads, update, delete operations. Block related to the logical expression implementation, and in loops you will find the blocks related to the loop instruction, and math contain the block used to implement the mathematical operation that include functions also. First, you find variables that consist of dynamic drop-down variables block, variable block, and fields which are dynamically typed to define the name and type. It's also to create and use new variables that can be categorized into main categories as a getter and setter. The text toolbox include the blocks which provide built-in fields for text inputs, storage, and printing the text in the smart contract implementation. Lastly, you have the library toolbox that provides some smart contract example. In order to understand how the SmartBuilder framework can be used, let's take an example of a payment smart contract in which Alice has agreed to pay Bob $250.5. So this smart contract will be executed only when the Alice balance is bigger than the amount. This is the requirement. And after the execution, the Alice balance will be deducted with the required amount, and Bob balance will be added. So we initialize the Alice balance to 3,000 and Bob initial balance is 2,000. After the contract is executed, the balance will be updated as follows. Let's make a model that can implement this smart contract. To implement that smart contract, the SmartBuilder give the possibility of combining the blocks that can be implementing the smart contract model in a logical manner. You have the initialization part that will be implementing the element that will set the parameters of the smart contract. Like here we have two participants, seller and buyer. Buyer is Alice and seller is set to Bob. So Alice balance is set to 3,000 and Bob balance is set to 2,000. This is the initialization part which is implemented. It basically will implement the smart contract that will pay Alice. That Alice balance will be deducted with the amount to be paid to Bob. So we have the invoke function that will be used with two participants, payer and payee, as well as the amount that need to be paid. The output of this model will be in several formats. Blockly enable the outputs to be extracted in a Blockly project, which can be saved and shared or reload for further modification. We have the project's XML script that describe the smart contract data structure and business logic. This file can be used in the decentralized application, and we have the source which is exported in a .go format to be deployed in the Hyperledger blockchain peer nodes. And we have the summary of the contract, which is provided in a text file in a natural language. Framework provides an easy way for user to build smart contract even without any knowledge of computer programming. So it has several benefits that includes simplicity. It's easy to use and simple. It's convenient and efficient for learning or teaching how to build smart contract, especially for Hyperledger Fabric smart contract, which is very complex. And it's provide low risk for making mistakes, as user doesn't code anything, but they only design the model using visual blocks that make it easy for them, and it doesn't expose them to many errors. And it's exportable. As I can see, the output can be exported and used, so the portability benefit is there, and is designed to be modular and extensible, so developers can extend it in order to build more advanced and complex smart contracts. So for that, they need to extend the library by providing more custom block that can be used by the user. This framework was adopted for commercial use by Bloco, which is business-graded blockchain technology specialized company in South Korea. So SmartBuilder is integrated with Argo platform of Bloco to apply Blockly-based formal specification techniques for designing and building commercial smart contracts. It's an hybrid blockchain platform for enterprise designed to leverage the benefit of the combination of public and private blockchain to provide support for smart contract implemented in general purpose languages such as C, C++, Go language, and so forth. Now let's have a look on a small demonstration to see how the SmartBuilder platform can be used to design and build a smart contract while using visual blocks. So let's have a look. Here you can see the user can use several blocks which are provided by the framework to build up the smart contract logic that's is based on the smart contract requirements coming from the natural language smart contract. And the user use Blockly to build the smart contract by connecting the blocks in a logical manner, and it's dynamically generating the smart contract source, as you can see on the right. This smart contract model can be extracted in XML and Golang and other several formats, as I mentioned earlier. So this is the way the proposed SmartBuilder framework works. To wrap up, in this presentation, I introduce SmartBuilder, which is a visual block assisted and user-friendly smart contract development framework targeting Hyperledger Fabric smart contract written in Go. It is based on Blockly, which is an open source client-side development library for user convenience, which doesn't require any server. It makes it easy for learners or non-expert users to build smart contracts using visual blocks without writing any single line of code. It is useful for teaching and learning how to build smart contracts more efficiently. In the future, we plan to develop more custom blocks to support several types of complex smart contracts and extend the framework to support other programming languages such as Java, Node.js, and so forth. So plan to develop an integrated smart contract security vulnerability and verification module, because the smart contract security vulnerability is still a very hard open issue that need further research. Thank you for listening to my presentation. If you have any question, you can reach me through LinkedIn, or you can send me your question through my email. And the project's source can be found on the GitHub repository provided in this link. Thank you very much.